In this lecture, I am going to discuss about two most important type of function. One is called sampling function and another one is called signum function. Another one is called signum function. Another one is called signum function. And you will see in the various courses of electrical engineering, these two functions have a wide range of application. When you will study Fourier transform, you will see the application of sampling theorem. Similarly, when you will study the various courses of electrical engineering, such as protection system, control system, process control, you will see the application of signum function. So to understand the various courses of electrical engineering, the sound knowledge of these two functions are very important. So first I am going to discuss about signum function. What is signum function? And then I will discuss sampling function. So first I am going to discuss about signum function. What is signum function? Let us consider any signal or any function xt, which is mathematically defined as xt equal to mod of t by t for any real value of t except t equal to 0. At t equal to 0, it is 0. Let us analyze this mathematical expression first to understand signum function. Now, here t is input. You can consider t as input and xt as output. So you can substitute any value of t. You can substitute any real value of t, or you can say any real value of input. So here t is the domain. T is called domain, and domain can be any real value of t. So it can be from minus infinity to plus infinity. You can substitute t equal to plus 1, plus 2, plus 3, plus 4. Or you can substitute t equal to minus 1, minus 2, minus 3. Also, you can substitute the value of t in decimal point 1.11, 1.22, minus 1.11, minus 1.12. You can substitute any real value of t. So you can say the domain has infinite set of value for this mathematical expression. You have option to substitute any real value of t. So domain has infinite set of value. But what will be the value of xt when you will substitute any value of t? This xt is called range. And I am going to show you that you can substitute any value of t, but xt uh, will be either minus 1 or it will be 0 or it will be plus 1. Means the range has only 3 discrete set of value. Either it can be minus 1 or it can be 0 or it can be plus 1. That is, for any value of t, xt will be either minus 1 or it can be 0 or it can be plus 1. So its range has only 3 discrete value. Such type of signal in which domain has infinite set of value, but range can be only 3 discrete set of value, which are minus 1, 0 or plus 1. That type of signal is called signum function. Let us analyze this signal through case by case. Let us consider first case. What will happen when t is greater than 0? What will be the value of xt when t is greater than 0? For example, if t is 1, 2, 3, or any positive value of t, what will be the value of xt? What will be the value of xt? Here xt is mod of t divided by t. And when you will substitute any positive value of t, for example, if you will substitute t equal to 2, then what you will get? You will get mod of 2 divided by 2. It will be equal to 1. What will be the value of xt when t is 3? You will get mod of 3 divided by 3. Again you will get 1. So in this way you can check the value of xt for any positive value of t. You will find xt will always be equal to plus 1 when t is greater than 0. Now let us consider the second case. Let us consider the second case when t is less than 0. For example, if t is minus 1, minus 2, minus 3, or any value which is less than 0, what will be the value of xt? In this case, xt will be mod of t divided by t. And for example, if t is minus 2, then what you will get? The mod of minus 2 by minus 2, and mod of minus 2 will be 2, and divided by minus 2, you will get minus 1. Similarly, you can check for any other value of t. Let us consider t is minus 3. What will be the value of xt? It will be mod of minus 3 divided by minus 3. And mod of minus 3 will be plus 3 divided by minus 3. You will get again minus 1. So in this way you can check for any negative value of t. xt will be always minus 1 if t is negative. And according to this expression, at t equal to 0, it is 0. So in this way you can see here, if you will substitute any value of t, or you can say you have infinite option for the input, but its output can have only three value. One is minus 1, which you will get when t is less than 0. Another one is plus 1, which you will get when t is greater than 0. And third one is 0, which you will get when t equal to 0. Such type of function is called signum function. In conclusion, you can say the signum function, the domain of signum function has infinite set of data, but its range will have only three discrete data. One is minus 1, which you will get when t is less than 0. Another one is 0, which you will get when t equal to 0. And third one is plus 1, which you will get when t greater than 0. Such type of signal is called signum function. This is the property of characteristic of signum function. And when you will draw a plot, when you will draw a graph, or when you will plot signum function or variation of signum function with respect to time, what type of characteristic you will get? You must remember signum function is usually written as S, G, N. This represents signum of t, which is a function of independent variable t versus t. If you will draw the characteristic of signum function with respect to t, what will be its characteristics? Let us check this. You have infinite option for t. You have infinite option for input, or you can say the signum domain of the signum function has infinite set of value. You can put any positive value of t. You have infinite option. And for each positive value of t, the signum function magnitude will be 1. You will get 1 always when t is greater than 0. You must remember this. And when you will substitute negative value of t, for example, -1, -2, -3, -4, when the value of t will be less than 1, less than 0, you will get signum of that t will be -1. So you will get this point, this point. So for t greater than 0, uh, signum t will be +1, and for t less than 0, signum t will be -1. And if you will connect these points, you will get plot like this. And what will be the value of signum t when t is equal to 0? This is very important. When t equal to 0, the signum t will be equal to 0. At t equal to 0, the magnitude of signum t will be equal to 0. Magnitude of signum t will be equal to 0. This is the point. So when you will connect all of these points, you will get plot like this. But you must remember, these are the magnitude of signum function. These are the magnitude of signum function. But at t equal to 0, the magnitude is 0. Again, little greater than t equal to 0, you will again get +1. And at t equal to 0, you will get 0. And when you will connect all of these points, you will get the characteristics of signum function. So this is the characteristics of signum function. And here, one point is very important. At t equal to 0, signum t will be 0. So this is the characteristics of signum function. Now, there are a few property of signum function which need to be understood also. Uh, Let us consider its first property. What will be the value of t signum t? T signum t. Suppose any function xt is defined as t into signum t. What will be its result? So you will see this will be equal to mod of t. You can justify this relationship by taking simple example. Let us consider first what will happen when t is greater than 0. For example, if t is 3, which is greater than 0, what will be the value of xt? The xt will be 3 into signum of 3. And as you know, when t is greater than 0, the signum function will be equal to +1. So this is 3 into 1. So this become equal to 3. So you can see here, when t is plus or greater than 0, the answer is also plus. Now let us consider the second case. What will happen when t is less than 0? For example, if t is -3, what you will get? In this case, your xt will be uh, t is -3, so -3 into signum t, signum -3. Here t is less than 0, and for less than 0, obviously, signum -3 will be -1, and it is -3. So again you are getting +3. So you can see here, whether t is positive or it negative, the xt will always be positive. Or you can say xt equal to t sin t signum t signum t is plus t when t is greater than 0, and it is also plus t when t is less than 0. So whether t is greater than 0 or less than 0, t signum t is always plus t. So you can write it as mod of t. So in this way you can justify this statement, this property. Similarly, if I am asking you, what will be the value of the function xt equal to mod of t signum t? This is the another property of signum function. You will get this will be equal to t. And also by taking a simple example, you can justify this statement. Let us consider case 1 when t is greater than 0. You can take any value of t. For example, let us consider t is 3, which is greater than 0. What will be the value of xt? Xt will be mod of 3, which is 3, and signum 3. And 3 is greater than 0, and for t greater than 0, signum function will be 1. So you will get 3. So here t is plus, you are getting plus. But what will happen when t is less than 0? Let us consider t is minus 3, which is less than 0. What will be the value of xt? Xt will be mod of t, mod of 3, minus 3, mod of minus 3 into signum minus 3, signum t, and in place of t, you have substituted minus 3. So mod of minus 3 will be 3. But for t less than 0, here it is minus 3, which is less than 0, signum function will be minus 1. So you will get minus 3. So you can see here, if t is negative, the answer is same as the value of t which you have selected. If you have selected t equal to plus 3, so answer is also plus 3. If you are selecting t equal to minus 3, then answer is also minus 3. So in this way you can say the mod of t, signum t, will be equal to the value which are selected. If it is positive, then it will be positive. If it is negative, then it will be negative. So you can write mod of t signum t will be equal to t. So all of these concepts I have covered in this PDF file. So you can go through this PDF file to understand signum function uh, clearly. And last I am going to show you the relationship between signum function and unit step function. Signum function and unit step function is related by this expression. You can write signum t in terms of unit step as minus 1 plus 2 ut. This is very important expression, and this mathematical expression will help you to solve various types of transformation. This is ut. Here, the characteristics of left hand side and right hand side are same. You know the characteristic of signum function. For t greater than 0, you know the characteristic of signum function. For t greater than 0, LHS will be 1. Left hand side will be 1. So now you have to check right hand side. What will be the value of right hand side when t is greater than 0? This will be equal to minus 1 plus 2. And as you know, when t is greater than 0, ut will be 1. So 2 into 1, you will get 1. So in this way, you can see LHS is equal to RHS for t greater than 0. Similarly, what will happen when t is less than 0? You know, for less than 0, signum function is minus 1. Now you have to check whether right hand side is minus 1 or not. Right hand side for t less than 0. What will be the value of right hand side? It will be minus 1 plus 2 into, as you know, unit step function is 0 for t less than 0. So 2 into 0 you will get minus 1 plus 0 you will get minus 1. So again you can see here LHS and RHS have the same characteristics. Now finally you have to check what will be the value of LHS and RHS for t equal to 0. As you know, LHS signal at t equal to 0 is 0. Now you have to check RHS. Very important. This t equal to 0 case is very important. RHS will be minus 1 plus 2 unit step function at t equal to 0. And in various research articles you can see, or in various book you can check the value of unit step signal at t equal to 0 can be equal to half. And you must remember it also. The value of unit step signal at t equal to 0 will be half. And when you will solve this expression, you will get 0. Again, you are saying, you can see here that LHS and RHS are equal. So in this way, you can say that signum t can be written as minus 1 plus 2 ut, or the signum t uh, and ut are related with this mathematical expression. And this is very important expression, because from this expression you can justify the value of unit step function at t equal to 0. It will be equal to half. So this is about the signum function, and this PDF file already I have given to you. So you go through this PDF file. Every concept have been discussed here. You can check each and every concept are given in this PDF file. So you can go through this PDF file for better understanding of signum function. Now the second function, which is very important, especially for this course, sampling function, because this function will help you a lot when you will discuss about Fourier transform, sampling theorem. When you will go through such type of uh, topic, you will see the importance of sampling function. And sampling function is basically is the ratio between sin t and t. Here sin t is the bounded function because its value cannot be, or mod of sin t cannot be greater than 1. It will always be less than or equal to 1. So this is a bounded signal. But t is increasing function of t. T can be 1, 2, 3, 4, 5, 6, 7, 8, any real value of t. And when you will draw a plot between bounded and increasing function t, a bounded function and increasing function t, when you will draw a plot of sin t by t, you will get a bounded sine wave like this. And this is a characteristics of sampling function. And this is unnormalized. This is unnormalized. You can normalize the sampling function just by converting this pi to pi by an integer. In sampling function, zero crossing is at plus minus n pi. Zero crossing will be at plus minus n pi. Here n is any integer except 0. It can be plus 1, plus pi, 2 pi, plus 3 pi, plus 4 pi, minus 2 pi, minus 3 pi. This is a sampling function. But when zero crossing will be 1, 2, 3, then you can say it is normalized. This pi, 2 pi, 3 pi is converted into in a integer. And when you will convert zero crossing from pi to some integer, 1, 2, 3, 4, then this is called normalized signal. When you will normalized this sampling function by writing like this, sin pi t by pi t. This is a normalized sig function. You are just normalizing the function. And when you will normalize the function, then this sampling function can be termed as sinc function. Here C represent for cardinal. You can say sine cardinal function. And here this is a -1, this one is -2, this is -3. So this is the graph of sinc function. So this is the difference between sinc and sampling function. This is a minor difference between these two. One has zero crossing at pi 2, pi 3, pi, and other has zero crossing at some integer value 1, 2, 3. So this is called sinc function. So this is the difference between sinc function and sampling function. And a detail about this signal you will also read in Fourier transform, because this signal has wide application, very play vital role for various or you can say in Fourier transform. When you will read the Fourier transform, you will see the application of sampling function. So you must remember this expression. And in addition to these two important function, uh, there is some important signal also, which the knowledge of this type of signal is also important. Causal, anti-causal, and non-causal signal. Its definition is very simple. You can easily understand its characteristic by this statement. For example, what is causal signal? You just see here, does not start before t equal to 0. A signal that does not start before t equal to 0. It will, its value will be 0 when t is negative. Then that type of signal is causal signal. Then that type of signal is causal signal. Its value in negative half will always be equal to 0. So that type of signal is causal signal. And what is anti-causal signal? That start before t equal to 0. It will not start before t equal to 0, but it will start. So this will become a signal that start before t equal to 0 is non-causal. Sorry, it is a non-causal signal. So one is causal signal and another one is non-causal signal. And what is anti-causal signal? The signal is anti-causal if xt will be 0 for t greater than equal to 0. Just it is up in opposition to first statement. Uh, in causal signal, that does not start before t equal to 0. But you can see here in anti-causal signal, it will be 0 for t greater than 0. Means for positive value of t, xt will be 0. Then it is anti-causal. And here you can see for t less than 0, xt will be 0. This is causal. So this is difference between causal, anti-causal and non-causal. So in conclusion, you can say that causal signal, in conclusion, you can say that causal signal is the signal that does not start before t equal to 0. And anti-causal signal is its value is 0 when t is greater than equal to 0. This is anti-causal. And what is non-causal? A signal that start before t equal to 0 is non-causal signal. So this is the basic difference between causal, anti-causal and non-causal signal. You will also study about causal, anti-causal system. This is about signal. In next lecture, you will see this type of system. So this is all about the signals. And from the next lecture, I will discuss about the various type of system: non-linear system, stable system, time variant system, time invariant system. I will discuss about the various types of system and its characteristics.